So we are currently working on a combined project. She's my mentor, like primary mentor, and then we just discuss stuff with him. So the project that we are working on is trying to find a zero lipid bilayer, which would be useful with other projects in the lab, including atomic force microscopy and dealing with some cool stuff on that side. My role is I am an undergraduate researcher and I work as a research assistant.
So the project that we're all working on here is one that's really focused on a fundamental interaction in biology, namely that which occurs between a protein and a membrane surface. So proteins and lipids, which comprise most of membrane, are really two fundamental entities in any life form, right? And it's actually surprising when you look in the literature and you realize that not much is known about how these two real fundamental biological components, how they interact when they're in close proximity to one another. And so our project is really focused on determining that interaction and doing so with the highest degree of precision that we can with modern tools. Okay, so the tool that we specialize in here is called an atomic force microscope, which one can think of as essentially a vanishingly sharp needle-like probe that one can attach a protein to. Once you have the protein attached to your probe, think of it as a fishing rod with the lure being the protein, and you can dangle that lure in the vicinity of a membrane and see if it bites, so to speak. And that's basically what we're trying to do. We're trying to measure the biting, if you will, between a membrane and a protein of interest.
So a lot of things that we know about proteins are from a biologist's point of view, and they usually do things like bulk measurements. So they know something happens, and usually they can have one or two theories about like why it happens. And what we're trying to do is define which one of those is actually happening. So why is this happening the way it is? And we can use physics tools to, instead of doing bulk measurements, think of like a really zoomed out picture of a school of fish or like the Tour de France, and we can zoom into that school of fish and see like 2 or 3 fish and see how they're interacting with each other, or see like 4 bicycles fallen in this big group of people trying to bike on a road, and we can see how they fell or why they fell, which is different than biology where you just kind of see the big picture.
I started with scratch almost because I was still learning stuff. Freshman year had been a hard toll on me, and it was just a little difficult to catch up with classes and devote equal time in the lab. So having set time aside during summer helped me polish those skills that were lacking. The most part that I learned was take good notes, okay? Because
That's a good life lesson.
yeah, don't miss on notes, because even if you miss on one point, just forgetting where the lipid is kept, even in the freezer, it's gonna take an hour to find out, or like ask others for help just to find out that lipid, where it's a huge stock, and just pointing out and opening one of them is not possible because it changes the temperature so rapidly. So taking good notes is the biggest life lesson. You can use that anywhere. Operating on instruments, we made the huge tent right there. It's nothing fancy, but we needed to find a way where others could also work in the same room as we were. So for fluorescence microscope, it's kind of important that you focus with minimum light as possible to avoid photo bleaching in it. So having a black tent that would cut off the light, it was a combined thing. She is good with stitching stuff, so credits to her. So yeah, having that set up took us a while, and now it's quite useful. Like, you can just be in the lab and still image simultaneously. So being in a lab is not just about focusing on your project, it's like also learning other skills that could be useful apart from the lab. Dr. King has been super patient with me, I'm not gonna lie. He's the one who has taught me, like, it's okay to have mistakes made several times, because if you don't make mistakes, you're never gonna learn from what's ahead. So, having prepared is not always necessary before you get started. You just gotta start in order to get it learned. I honestly have spoiled so many instruments around the lab, but reading and revising the protocol before you actually start in a research is again a key component, which he also taught me a lesson about it. And there wasn't ever a time where he cut short. It was always a brief discussion about this is what you're doing wrong, this is what you should get corrected, and this is how we can achieve and be on the path that we were looking forward to. So yeah, having that dedication from the start is required if you are actually serious about anything that you do.
I'm still quite a young grad student in my career and in the lab, and so when Dr. King was like, hey, I want you to mentor this girl, her name is Vishvi, I think we'd maybe had 2 or 3 conversations, and I honestly hadn't used a microscope in maybe 6 or 7 years. And so Vishvi really brought into the lab kind of this new flavor of research. She has a skill set that I definitely didn't have. And we didn't really have any information about the tool we're using other than, like, this is how you turn it on. Like, we even had to find the program to take the data on our computer. And so working with her has been an experience, not just because now I can't just rely on myself, and if it's my mistake, like, it's my mistake. But if Vishvi makes a mistake, I have to sit there and go, okay, how can I help both of us learn from this? And so it's a different way of thinking. It's not, every man for himself, but it's how can we work as a team and make this a valuable experience for everybody.
In terms of undergraduates getting involved with research, I think, I'm a huge proponent of that. And ever since I started here, I've always enthusiastically embraced a few undergrads, and they've been extremely productive in my view. For me, it's just really exciting to work with a young scientist. And, I think graduate school and the process of sort of pursuing a scientific career is great, but it also sort of comes with a lot of I don't know the right word to use. It's hard, right? There's a lot of flaming hoops that you have to jump through, and it sort of grinds you down over time. But as an undergrad, you're fresh, you're young, and you haven't had to jump through those flaming hoops, etc. And so there's something about working with an undergraduate in general that's really refreshing. And you might propose a really ambitious project, a really sort of bold new direction, and they'll just jump right into it and say, yeah, I'll do that. Whereas a more seasoned graduate student would be able to say, oh, that's never going to work. Right?
Yeah, I agree.
And but I enjoy that. And because even if an undergraduate's project doesn't come fully into fruition, they'll still learn a lot, right? So even if, you don't get to exactly where you want to be, if you get halfway there, you're still going to be, well on your way to learning and a productive scientific career after you graduate. So I really enjoy undergraduates in the lab. I think they bring a fresh energy and so on. So
It's dry enough.
I agree with them because sometimes classes are just so monotonous that you really want something that's hands-on, or just realizing what you're actually learning in classes, because that's theoretical. What am I gonna do if I don't really know the practical side of it? So I was ready to work on anything because one, I wanted the lab experience and I was excited to join the lab. 2, I actually wanted to see how my majors would compile into it. What if I actually seek to pursue a scientific career, what it would actually look like. So yes, I agree with both of them, and I would highly encourage to take up undergraduate research and not give a second thought about it.